So I'm going to talk about the robot that can guide itself to the trachea today. No disclosures. Airway management in acute trauma is very important. This is because it has impact on survival or long-term recovery. And it's also known that under limited medical resource condition, this gets worse. So autonomous endotracheal intubation could mitigate this issue. We hypothesized that by using deep learning object detection, we can build a continuum robot that can guide itself to the trachea. So this is a system diagram. The robot carries a camera, which then feeds the image to the image detection computer, which then detects the trachea in the image and sends the positional information of the trachea to the robot control computer, which then guides the robot to the trachea. And I'm going to talk about this ROS later. This robot has 3 degrees of freedom. One is plunge, one is rotate, one is bend. This bending section is single and it's 90 millimeters in length. As for robot guidance, we utilize the object detection algorithm named YOLO version 3. This is highly efficient convolutional neural network-based algorithm, and it's often used in a real-time detection. It has 53 convolutional layers. We couple this with medium flow tracking. As for robot control, we use a platform named ROS. ROS is an operating system for robots. And using this ROS, we built a control scheme consisting of 3 different modes. And so the robot starts off with the searching mode where trachea is not detected yet. And it conducts a predefined searching motion complex, SMC. And as detection is established, it transitions to the tracking mode where the robot tries to go nearer to the trachea. And as it gets nearer, it transitions to the inserting mode. And here, the robot utilizes a predefined inserting motion complex, IMC. So we conducted an experiment using a phantom and for the robot to move from the oropharynx to the trachea. This is searching mode, this is tracking mode, this is inserting mode. We use the success rate as a metrics. So our system could achieve success rate of 96.7%, which was significantly higher compared to searching motion complex only, or inserting motion complex only, or blind manual insertion. So this is a demonstration video. This is a searching mode, and it now establishes detection of trachea. So now it gets into the tracking mode. In tracking mode, the robot tries to adjust the position of the robot so that the detection bounding box comes to the center of the screen. So as it proceeds, the robot keeps adjusting and adjusting. And as it approaches to the trachea, it transitions to inserting mode. So now it's inside the trachea. So our hypothesis that the autonomous endotracheal intubation is enabled by deep learning was validated by phantom study. So we expect this technology to be useful in various settings of acute trauma accompanied by medical resource limitation. Thank you.